Hello, everyone. My name is Colin O'Keefe, and I'm going to teach you about probability, which is one of the hardest things, in my opinion, about math. Probability and statistics is one of the hardest things to learn in math. So, first things first, we need to know the words that I'm going to be using in this video. So the first word that I'm going to be using and you need to know for probability is the actual word probability. The definition of probability is the likelihood of an event occurring. And sometimes we represent this as P over, or P to the A, or PA, which is basically the probability of A happening, or probability of B happening, or whatever is in this parentheses, which basically means number of times A occurred over total number of trials. So throughout this unit, that there's many different formulas that you need to know, and these formulas have different names. So the first formula that I'm going to be talking about is called combined events, and combined events is basically a set of one or more possible results in an experiment. This will all make sense in the next slide because I have all the formulas laid out and I'm going to explain them more in depth. The next thing that we need to know is mutually exclusive. Mutually exclusive means two events that don't occur at the same time, which in the IB problem will give you that formula that it will actually say these events are mutually exclusive. The next thing that you need to know is conditional probability, which basically is the probability that a given item will happen and the second will definitely occur. The next idea that we need to know is independent events. An independent event is basically saying one event doesn't affect the other, so they're independent. They don't affect each other. So these are the words that I'm going to be using throughout my video. So these are the ones you need to study and look over. So now we went over the words that we need to know for this video. We're going to look at the formulas that we need to know for this video. And in general for probability, these are the four main formulas that you will need to know for this unit. So for the first one, it's the combined events formula, which back in the words to know, combined events is a set of one or more possible results in an experiment. So we know that this, like we said before in the words to know, or it's basically a symbol to know, this is basically the probability of A happening. This is the probability of B happening. And now we're left with this weird arrangement of letters. So what this basically means is the probability of A and B happening. So this is like the intersection. This means the union. So the probability that A union B will happen. And so knowing that, all these mean the same thing. So you just need to plug in what all these, it will give you these letters in your problem, and you have to plug it into the formula, and the numbers, you'd have to plug it into the formula. So like I said before, mutually exclusive events, it's basically going to tell you that in the problem. It's going to say these events are mutually exclusive. So that one isn't that hard. Conditional probability is this formula. The probability of A and B happening equals the probability of A times the probability of B given A. This means given right here. This is the probability of B given A. So you're given A and you're trying to find B. And then, like I said before, independent events is basically two events that don't affect each other. These are formulas that we need to know, and in the next slide, I'm going to be talking about different problems that we need to know. Okay, so for IB, a common practice problem that will often occur is that, or often will show up, is something like this. So you'll be given a problem and then a chart, and you're gonna be asked to fill out the chart and then answer a few questions about it. So this question is, in a survey, 100 students were asked do you prefer to watch television or play a sport? Of the 46 boys in the survey, 33 said that they chose a sport, while 29 girls made the same choice. So first things first, we're going to fill out the chart. And to fill out the chart, it's basically just simple subtraction and addition. So we have to figure out, first I'm going to do the first column, boys. So we have to know that 33 and some number equals 46. So you can just do 46 minus 33, or just do it in your head, which is 13. And the next thing we need to do is, we can do is figure out the total number of sports, people that play sports, boys and girls. So you just add 33 and 29, and you get 62. You can use a calculator or do it in your head, however way works for you. So now we have that. Those are the two that we have. Now we could subtract 100 or 62 from 100 to get this total number of boys and girls that watch TV. So 100 minus 62 is 38. So 38. And now 13 plus what gets you to 38? 25 is the answer. And now 25 plus 29 is 54. And that's pretty much how all the problems are going to be. You're going to have, or that are like this, set up like this. Eventually you're going to get one of these problems. So then you first want to just fill out the chart like I did, which will take you like 2 seconds to do. It took me a little while because I was explaining how to do it. Now let's solve the problems that are given. So now the first question is, find the probability that a student selected at random prefers to watch TV. So now we're saying the probability of a random person that watches TV. So now you have to find that the total, so the total number of people is 100. So we can put the 100 right there. So that's like our trials, like, you know, back in the words to know, it was the probability of A, which was basically the number of times A occurred over the total number of trials. This can be the total number of trials, or in this case, people. So now we have to figure out the numerator. So it's basically how many people watch TV. So we said our total was 38. So 38 goes on top as your numerator, and that's your answer. So you can either leave it like this or leave it as 0.38, or however you want to show your work. So the next thing is find the probability a student prefers to watch TV given that it is a boy. So now we know that it's a boy. So we're trying to figure out the probability of a student that prefers to watch TV given, like I said before in the formulas, that this is the given sign, that given that it's a boy. I'm just going to write boy. So now we're going to be basically using our chart. So our boy, we're given boy, or that's the total amount that we have, boys, just 46. We're given that. And now, how many of these boys like to watch TV? And we figured out that 13 of them do. So then that's your answer. It's as easy as that. So now you can either you can leave it like that, or in IB you'd like to round it to 3 sig figs. So you'd put that in your calculator and figure out what it equals. And I've already done that, so it equals 0.283 to 3 sig figs. So this is just one problem that will commonly occur in IB, or just in general, some practice or some probability problems. Okay, so for the next practice problem, it is a different style. So the problem is for the events A and B, the probability of A equals 0.6 and the probability of B equals 0.8. And the probability that A union B equals 1. So now this is like a formula based question. So now our first question is A, find the probability of A and B. So we can look at our formulas, plural, and we can use this formula because of A, B, and this, because we're given that. So now to make this go over there, we can just add this to that side to figure that's what we're figuring out. So we can put that on the equal side and then subtract that. So it's just basically switching these. So now that's what I'm going to do. So in our formula, I'm going to bring that back out here. In our formula, the P of A, or probability of A, equals 0.6. So 0.6 plus probability of B, which is 0.8, equals, or minus, and we switch these two, so that'd be 1 minus 1 equals this. So our probability of A and B. So now we just solve this equation. These equals 1.4 minus 1, that equals 0.4. So 0.4 equals the probability of A and B. Okay, so for part B, we can just do, so I didn't really talk about this, that this like accent mark right there, or this apostrophe right here basically means the opposite. So the opposite out of 1. So the opposite of the probability of A would be 0.4, because 1 minus 0.6 equals 0.4. So basically what plus that gets you to 1. And to solve this, we can take this and put the inverse over it, and the opposite of this would be A, this, B. So the probability of this. So we're just moving that to the outside. And to solve this, we already know that it's 1, or we've solved it over there, which is 0.4. And then we take the opposite, since it's out of 1, so we subtract 1. So what plus that gets you to 1. And if you do 1 minus 0.4 equals 0.6, which is basically your inverse of that, which is what we were trying to get to in our problem. So to finally finish it out, it's A, B equals 0.6. So this is how you can use the formulas in a number problem. Alright, so I haven't covered everything that there is in probability. That would take too long. I've covered 2 problems that you will most likely face when discussing probability, and I went in depth in explaining these 2 problems. And right now I'm going to assign you some practice IB problems, and here's one of them, which is basically the chart one that we did in our first practice problem, which was this one, like we did earlier. So this one is in a survey of 200 people, 90 of whom were female, it was found that 60 people were unemployed, including 20 males. So that's all you're given, and you have to fill out the chart by yourself. I just gave you that the total number of people is 200, which is, or it should already be on there. So what I want you to do is complete the chart above. B tells you, if a person is selected at random from this group of 200, find the probability that this person is either an unemployed female or a male given a person is employed. It's just that simple. It's a pretty simple IB problem, but it will help you towards understanding this topic. Okay, so for my next problem for in the IB exam style question, I picked two, or like one question, but it's like a two-parter, but like separate ones. It's kind of confusing, but these two problems reflect the IB exam style questions. The first one says, the first part of it is two events, A and B, are such that probability of A equals 0.3 and the probability of A union B equals 0.7. So now you're trying to find, given that A and B are mutually exclusive, find probability of B. And all you have to do is use the mutually exclusive formula and solve for B. The next thing, I just wrote two things that you have to do. And this is basically independent probability. So, or you have to figure out what probability, which I kind of just told you, but you have to figure out which probability you have to use, and you have to solve it. For these two IB exam style questions that I assigned for homework, I'm going to provide an answer key at the end of this video so you can check to see your progress and see if you got these answers right, so you understand what topic or what I was discussing. Well, this is my video, and this only just touched the surface of probability. I only discussed basically like two things. I just made a chart, and you used the chart to figure out how to use probability, and then I used number problems. So I hope you learned at least one thing in this lesson, and I hope you have a good day.